Hello and welcome to this repair tutorial, and today we're going to look at an Arcam and the model number is Alpha 2. This amplifier was produced round about 1991, and in terms of general specifications the amplifier provides an RMS power output of 30 watts, and that's when you connect 2x 8 speakers. It also has switched and unswitched rear speaker output. So just for clarification, what that actually means is if you connect the speakers to the switched terminals, if you plug in via the 1/4-inch headphone jack socket, it will disconnect the audio output. If it's unswitched, then that simply means that even if you plug in the headphones, the audio will continue to be heard. As you see, headphone socket, which is always a nice feature on these older amplifiers. And in terms of frequency response, you're looking at 30 Hz up to a maximum of 20 kHz. And then total harmonic distortion comes in at 0.5%. And then input sensitivity, because you can also connect a turntable directly to it with a moving magnet type cartridge, is 2.5 millivolts. And then for all of your other inputs, you're looking at 200 millivolts. And overall dimensions are 400 width by 95 height by 231 millimeters depth, with a weight of approximately 4 kilograms. Now, this amplifier came in from a customer who contacted me via the YouTube channel, and what the customer advised was that this amplifier would not power up. What you can see here is that there is a rear protection fuse, and you can see that there's a fuse holder there, and that is the power input protection fuse. So the mains comes in, and then this would be on the primary side of the toroidal transformer, and then to the left of that, audio output transistors. Now the fuse rating inside of there is 630 milliamps, and it's an anti-surge type fuse. Now if you remove the top cover, what you found was that the fuse was open circuit, but most importantly the fuse hadn't vaporized, so that tended to tell you that it hadn't drawn excessive current, and maybe the fuse had failed during a power up, and it could be age related or just a slight surge, and that's what you found here. So what happened was that the fuse was replaced and the amplifier powered up then via the gimbal tester, and I've put a link in the description to the video just so you're aware of it if maybe this is relatively new to you and you've not come across the term before. And really, what was the course of action next? Well, we could of course just replace the fuse, but as I continually say in all of these repair tutorials, once you have the amplifier on the bench, that's really the beginning of the work. And what I'm referring to is that you need to do additional work, not just fix the fault, which will then bring back longevity to the amplifier, because an amplifier which is coming in from 1991 will of course have particular issues relating to the age of the amplifier, and sometimes it can be impacted as well by the environment that the amplifier was in. What I can tell you is that this amplifier was in exceptionally good condition, and the customer had also provided the original box packaging material, so really a delight to work on. So the first thing that you need to do is on the top and the bottom you have the cover plates, and they're very easy to remove. You just have two fixing screws which are mounted, actually screwing to the rear heat sinks for the output transistors, and then if you just sort of take like a hook tool, you can just lift them up and then just remove them. And then what I'm showing here is the bottom of the amplifier, and what you can see is the circuit tracks, and you can also see the multiple solder joints as well. Just for information, on the left hand side you can see a piece of plastic, and what they've done there is they've just got a self-tapping screw, and that just provides additional electrical protection because that's where you have the mains voltage coming in. So to get access to that part of the board, just unscrew it and then you can just move the white plastic material out of the way. So the course of action here, as with all amplifiers, is really to verify that these solder connections are good. Now what you'll find is, and again it's not because of manufacture, there's quite a lot of dry solder joints on these amplifiers. And you really have to just take this systematic approach where you just block solder really all of the circuit board and pay critical attention, particularly where you have the user control. So these are the switches which are operated from the front, and also the potentiometers. Because they are under some degree of mechanical stress, then you can find that these solder joints start to break away. You'll also see the input selection switch, which we'll come to in a moment, which is typical of this generation of Arcam amplifiers. And you saw it on the later units where they used the same type of switch, for example Alpha 7s and Alpha 8s. So here if we look with the front bezel removed, now if you're going to remove the plastic bezel on these amplifiers, there is no fixing screws. You can actually see that there are 3 slots looking from the left and then moving across. So there's one left and then right and then one in the centre. And these plastic tabs just push through and then clip in place. And then you can see what I'm indicating with the arrow is I'm pointing to the input selection switch. And typically with the input selection switch you have a couple of issues. The first one is that you could have dry solder joints on the pins, which could result in intermittent loss of sound. But more commonly what you'll find is that the switching contacts internally become oxidized. And that oxidization then leads again to this issue with intermittent switching. Now I'm pointing to the locking nut, and for people who are familiar with working on audio equipment, it may be that you wish to use maybe a pair of long nose pliers to remove these locking nuts. What I would advise you to do is not to do that, and the reason is that if the locking switches may be very tight, or you may accidentally slip with the pliers and then cause damage, either to the knurled thread on the switch or on the potentiometer, or even like to the fascia. So it's one of these points that you always need to use the correct tool for the job. So you can use maybe an adjustable spanner or the correct size socket to remove it. And then here, if we just sort of zoom in, not to spend too much time, you can see here, the locking switch in position. And then once the switch has been desoldered from the board, what I've done here is I'm just showing you the switch taken apart. Now it's easy to do, okay? What you'll find is that there are 4 tabs which are bent over to this metal plate, and you just take a small pair of pliers and then you just bend them straight. And then you can just prise off the metal plate at the rear, and then the 2 wafers, which you see here, and this is the terminology which we use for the switching contacts. The wafer 1 comes apart, and then wafer 2 you can leave in position. So what I simply do is I just use something like Servicol Super 10 just to remove the existing grease which would have been in there and completely dried out. And then I then take a fiberglass pencil just to rotate it around the contacts, and they will come up very, very bright, and then I'll apply a De-Oxit grease into there, just a small amount because they're slipping metal contacts. And then the green component or part that you see sort of centre of that, that's the actual wiper for the switch. Just be careful there because that sort of the metal parts just position themselves onto 2 pegs, top or bottom, but just make sure you get the correct alignment when you do the disassembly. So once you've cleaned that switch up and then of course refit it, solder it into place and put the locking nut on, you are guaranteed then that you will have no issue with any intermittent loss of sound via the switch. Now this amplifier does not have any form of speaker protection relating to an electromechanical relay. What it does have are fuses which are mounted on the circuit board, 20mm, 5mm, 2A fast blow, and those are the protection fuses. And then here if we look from the top, this is looking towards the front with the bezel removed, and then what you can see on the left hand side is a toroidal transformer. And then you can see towards the front we have the user controls, so these are the potentiometers. And then just to the right you can see that the switch is being used then for the tape selection, and then right next to that you can see the input selection switch which has been remounted back into the amp. On the full left hand side you can see like a black component, that's the headphone socket, and then as you move towards the rear of the amplifier you can see the orange wires and the blue wires, that's the secondary of the toroidal transformer connecting to the main amp board, and then you can see the 2 vertical electrolytic smoothing capacitors, and then the left and then the right hand channels for the main audio output. Now when you talk about user controls, and this is a common term that I use, what I'm referring to are the adjustments that the user would make. So they could be switches, they could be potentiometers, maybe to operate the volume, bass, treble controls. Now what happens is that over time these contacts become dirty, so the carbon tracks within the potentiometers become dirty. And then if maybe you connect your headphones or maybe the speakers are connected, as the user rotates maybe the volume, then you hear this crackling or this rustling sound, or you might see some form of deflection on the speakers, and it's extremely annoying and it shouldn't of course be there. So what you can do is you spray directly into there, these holes, and then you can apply De-Oxit, and then you can just rotate the potentiometers backwards and forwards. Just let the De-Oxit do its work, leave it in there 30-40 seconds, and then just rotate backwards and forward. What I do is I don't connect the amplifier to speakers, I put the headphones in and then I can listen. What you'll find is maybe at the extreme limit of the potentiometer or right at the beginning, that's where you tend to find most of the dirt. So you just got to keep as I say, rotating backwards and forwards until you hear none of that crackling sound or sort of scrapey sound anymore. And that tells you the De-Oxit has done its work and that those potentiometers are clean. And then here for the amplifier, you know, what's kind of like your next step? Because we fixed the power input issue, we did all the dry solder joints, and we've now cleaned the user control potentiometers. Well, what I've done here is I've taken an extract from the service manual, and the service manual is old school, so it's very, very well documented, and it tells you the changes between the Arcam Alpha, the first one, Arcam Alpha 2, and then the Arcam Alpha 3 amplifier. Different modifications. So what I need to do here is I need to look at setting the bias for both the left and the right channels. Now remember, this amplifier has never been worked on before, so when it left the factory those adjustments would have been correct, but over time you find components age and then drift, and then subsequently it will need realignment. And the task is very easy. So what I'm saying here is that you have on the board two potentiometers, one for the left, one for the right. And then what you find for the output transistors, you have dual emitter resistors. And all that you need to do is just to set your multimeter to millivolts and then connect via your hook clips across one of the emitter resistors. And for the Arcam Alpha 2, you're looking to adjust it until you have a value of 8 millivolts. So that means that you do not connect any speakers, you do not connect any inputs, you set your volume control to minimum and your balance, treble and bass to midpoint, and you leave the amplifier according to the service manual for approximately 30 minutes in a stable environment, no drafts, and then once you have that condition met, you can then make the adjustment. And then here what I'm showing you are the emitter resistors. So on the board it's got test point 1, test point 2, so you just need to connect to either one of those. And then to the right hand side what you can also see is one of the fuse carriers. Just for a point of interest, and this is important for all of these types of amplifiers, you may have an intermittent contact with the end of the fuse, so just remove them, check them, and then squeeze them in if they may be loose, and then you can snap the fuse back into place. And as I said, on the right hand side just towards the front you can see the black potentiometer, and that is used then to adjust your bias. And then here what we're showing you is on the left hand channel when we first connected, it's not 8 millivolts, it's way down, so it's about 5.61 millivolts here. Don't be concerned about the polarity, it just means that the multimeter leads are just connected to the opposite ends of the resistor, so it would have been a case of just turning them around just to get a positive reading. And then what you need to do, as I said, is just to make the adjustment. So here the amplifier was left for about 30 minutes, and then I've then made the adjustment to put the amplifier back to the factory value, which is 8 millivolts. And then here for the right channel, what you can now see is that it's quite low. So now you're down at 2.18 millivolts. So again, same procedure, and you can see the hook clips are now on the other set of emitter resistors. All that we've done then is we've just done the adjustment to bring it back up to 8 millivolts. And then what you can see here is the emitter resistors just underneath that multi-core flat cable there. And then what they do here is on the right channel, they simply just increment the number for the component. So for example, if you're on the left channel, then it will be RV1, and then as soon as you go to the right channel, it will increment by 100, so it then becomes RV101. The same for the components on the board. So again, if it was a resistor and it was R10, it would be 110 if it's then on the right. So once we did the alignment, we're just really coming back on this photograph, and what you see are 4 rectification diodes. Now I have had instances where the power input fuse will blow and your automatic reaction is to think that maybe the audio output left or right has failed, one of the transistors has gone short. What you can find is sometimes one of these rectification diodes will fail short, so just be aware of that. And then here what I've done is I've just zoomed in just on the phono stage. So as we said, this is a moving magnet type input, and what they've done is they've used a small operational amplifier, and then at the rear you can see that there's a multi-pin connector with some links on there, and as it says, for the MC option, make sure that the plug is aligned correctly. And I think what's always nice with these older amplifiers, you can even see here they put an image onto the circuit board to describe the pinouts for the TIP outputs. So you can see what would be the base, collector and emitter, and then also for the BC components, and then also for the other transistors which were FST type. Just nice to see that. So really that sort of brings us to the end of this repair tutorial. So the amplifier underwent a test, so normally here probably for about 2-3 hours continual operation, and as I said, there was no sort of concerns with the operation, all was good. I am a fan of these amplifiers. I've worked on them extensively over a number of years. I'm always very impressed at the performance of these amps, and to restore them back and then to get them operational again is a real joy and a pleasure. So as always, I appreciate you stopping by, and if you require any help, support or assistance, by all means you can email Audio Amplifier Servicing at aol.com, and I'll be more than happy to come back to you and provide any support that you may require. So until the next time, I wish you all the very best. Cheers and bye-bye.